Hey, welcome. You know, if you think about writing software like you're an architect building a skyscraper, then design patterns, well, they're your master blueprints. They're what really separates the good code from the great professional code that you can actually maintain. So let's get building. I mean, you know that feeling, right? You're staring at your code and it just hits you. Wait a second. Haven't I written this exact piece of logic before, just somewhere else? It's that nagging feeling that you're just constantly reinventing the wheel. But what if there's a smarter way to work? Well, there is. And this is exactly where design patterns step in. Now, here's the most important thing to get right away. These are not libraries. They're not finished code you can just copy-paste. Think of them more like battle-tested strategies or, blueprints that show you an elegant way to solve a problem that developers have been running into for years. Okay, so we're going to look at three big categories, and we'll start with creational patterns. And just like the name says, these patterns are all about one thing: how we create objects. They're designed to give your code a ton more flexibility in how things get made. Here's a great way to think about it. Imagine a giant car factory. You don't just have one single machine that spits out a car, right? No way. You've got specific assembly lines, one for the sedans, another for the SUVs, a whole different one for trucks. Creational patterns bring that exact kind of organized, specialized logic right into your code. So let's check out a classic example, the factory method. The real beauty of this pattern is that it lets a parent class define a general process for creating an object, but then it lets the subclasses decide which exact kind of object to create. It's all about delegating that responsibility. So instead of that giant, ugly if-else block that we've all written, the one that you have to change every single time you add a new document type, you have a clean create document method. Your Word document creator knows how to make a Word doc. Your PDF document creator knows how to make a PDF. It's clean, it's simple, and it's so much easier to add more later.
Okay, but like any powerful tool, you gotta know when to actually pull it out of the toolbox. It's not for every single situation.
So here's the deal. Use the factory method when you need your code to be super flexible, when you don't know ahead of time exactly what kinds of objects you're going to need. But look, if your object creation is simple, like you're only ever going to make one kind of thing and that's never going to change, then this is just over-engineering. Just keep it simple. All right, next up, structural patterns. So if creational patterns are about making objects, structural patterns are all about how you put them together. They show you how to assemble classes and objects into bigger structures while keeping everything flexible and efficient. And the analogy for this category is just perfect. Think of a universal power adapter. You're traveling, right? Your laptop plug doesn't fit the wall socket. What do? You grab your adapter. It doesn't change your laptop, and it doesn't change the wall. It's just a bridge, a translator, that makes two things that were incompatible work together perfectly. And that brings us right to the adapter pattern. Its whole job is to be that translator in your code. It wraps around an existing class, gives it a new interface, and suddenly it's compatible with the rest of your system. Oh man, we have all been in this situation. You find this incredible new third-party library that does exactly what you need, but its methods are all named differently from what your app expects. Instead of rewriting huge chunks of your code, you just write one little adapter class. It takes the calls your app makes and translates them into calls the new library can understand. Problem solved. Now, this slide is actually super helpful because it clears up a common mix-up. An adapter changes an interface to make things compatible. That's different from a proxy, which uses the same interface but controls access to the object. And it's also different from a decorator, which also uses the same interface but adds new features. Knowing which one does what is absolutely key. And that brings us to our third and final category: behavioral patterns. These are all about communication. They focus on how your objects talk to each other and who's responsible for what, making sure they all work together effectively. Okay, think about ordering food at a restaurant. You don't just run into the kitchen and yell your order at the chef, right? Of course not. You tell the waiter, who writes it down on a ticket. And now that ticket, that request, has become its own thing. It can be put in a queue, it can be logged for the bill, it can even be torn up if you change your mind. And that is the absolute essence of the command pattern. It wraps up a request into a standalone object. That order ticket is the command object. This lets you do all sorts of cool stuff, like queue up requests, log them, and even support undo. And this is where the command pattern really shines in a practical way. So picture a button in your app. Without this pattern,
clicking the button is directly tied to the code that runs. But if the button click creates a command object instead, you've separated the request from the action. Now you can just save that command object in a list, which makes building an undo/redo feature surprisingly easy. So what are the best situations for using a pattern this cool? Simple. This should be your go-to pattern anytime you need that undo/redo feature, or you need to line up a bunch of tasks to run later, or maybe you need to log a complete history of actions. But again, if you've just got a simple button click that does one thing and doesn't need any of that fancy stuff, this is probably overkill. So we've just taken a quick look at one pattern from each of the three major groups. But really, this is just the first step in building out your professional design toolkit. The classic Gang of Four book, the one that really kicked all this off, it actually lays out 23 core patterns. And when you first see that number, yeah, it can feel a little intimidating, like you've got this mountain of stuff to memorize. But here is the most important takeaway of this whole thing. The goal is not to memorize all 23 patterns. The real skill, the thing that makes you a better developer, is learning how to recognize the problem you're facing. Once you can clearly identify the problem, you can then go find the right blueprint for the job. And that brings us full circle. They really are your architectural blueprints. They give us all a shared language to talk about software design, and they offer proven solutions to those tricky problems we all run into, letting us build software that's way more robust, flexible, and easier to maintain. So, I'll leave you with this question to chew on. Take a look at the code you're working on right now. Is there a tangled-up if-else block, an incompatible library you're struggling with, or maybe a missing undo feature that's just begging for its perfect design pattern to come along and clean things up? Happy blueprinting! Thanks for watching.